Hey, we're moving on to Unit 6 now. Standard 6.1, divisibility and factors. This is kind of interesting stuff. Hopefully some of this is stuff you're familiar with, and hopefully some of it's stuff that sticks. All right, Standard 6.1, I can find the greatest common factor of an integer. All right, so we have some conceptual stuff to talk about here. First, 12 divided by 4. You probably know this answer, but here's one way we can demonstrate what we know. So I'm going to switch over here to the highlighter. All right. So I'm going to say, okay, we're going to divide 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 into groups of 4. There's a group of 4. There's a group of 4. There's a group of 4. It didn't change colors. There's a group of 4. All right. So how many groups of 4 did we get? We got 3. 12 divided by 4 is 3, right? That's division, right? We're going to put 12 into groups of 4, see what's left. What happens if we do that with groups of 5? What are we going to get? So let's start with it again. Let's start with yellow. 1, 2, 3, 4, 5. Right. Pink again. 1, 2, 3, 4, 5. All right. What happened? We got 2 left over. That doesn't really work. We got these 2. So this is what? Well, we could call it a decimal, but sometimes you guys used to call these 2 with remainder of 2. Maybe that. All right. Or maybe you could say, this would really be 2.4. So it just doesn't really work. Here's the deal. Divisibility, something is divisible. A number is divisible by another if, the remainder is 0. So that's like this situation, right? We broke it up into even groups, nothing left over. Here is a remainder. So this number is divisible, this one's not. The remainder is the amount left over when a number is not divisible by another. Okay, so when we talk about divisible, that means it can go into there fully, right? 4 fully goes into 12 3 times. 5 does not go fully into 12, right? It goes in 2 times with some left over. So there are divisibility rules that we can use to help us determine if the divisor will go into the dividend evenly, right? So there's a bunch of rules, but we're going to focus on 3 of them. They're kind of interesting how they work. So this one's really easy. 2, the ones digit, so the smallest number, the one furthest to the right before a decimal, is even, also known as 0, 2, 4, 6, or 8. All even numbers are divisible by 2. Means 2 goes into it evenly, right? That's pairs, right? That's kind of how you guys learn it. Next step, 3. For 3, the sum, so adding, let me add that. I'm going to say adding. The sum of the digits is divisible by 3. I'm going to take the numbers up, add them all up, then divide it by 3, and if it's divisible by 3 then the whole number is divisible by 3. I'm going to show you kind of what that means when we get to it, okay? Then question 5. Or not question 5, number 5. The ones digit is 5 or 0 or 5. All numbers that end in 0 or 5 are divisible by 5. No other numbers are. There's nothing that ends in a 3, nothing that ends in anything else. Always 0 or 5. And 10 is probably the easiest one of all. You guys probably know this. If the ones digit is 0, you can divide it by 10. It's divisible by 10. All right? So let's take a look. What's that actually mean for us? Well, here's some stuff. Let's think about this. Use the divisibility rules to determine if each statement is true or false. So here's our first one. 32. Is 32 divisible by 5? Well, our rule for 5 was the ones digit had to be 0 or 5. Here's your ones digit. Is that 0 or 5? No, it's not. So this is false. 32 is not divisible by 5. 2. 577 is divisible by 2. Our ones digit has to be 2, 4, 6, 8, or 0. Nope, that's a 7. It's not one of those, so false. 3. 440 is divisible by 3. Well, here's how you do that. You're going to do 4 plus 4 plus 0. What's 4 plus 4 plus 0? Well, that's 8. 8 has to be divisible by 3. Or another way to think of it is it could be 3, 6, or 9. Those could be your options. 8 is not 3, 6, or 9. It's not divisible by 3, so it is false. 4. 688 is divisible by 10. We're going to look at the last digit, see if it's 0. It is not. It is false. These are all no's, right? So that was just a small example of how I'm going to think through it, right? You can do big numbers. That's the point of this. It's not numbers that you memorize. It's numbers that you know the rules so you can apply it to bigger numbers. So let's see what some of those are, okay? We'll do some together. So here's the next one. Factor is the same thing. So factor is an integer that divides another integer without a remainder, right? So it means the same thing of what we just talked about. Is it divisible? So is 2 a factor of 111? Well, we're looking at that last digit right here. Is that 2, 4, 6, 8, or 0? No, so it's false. 3 is a factor of 114. 1 plus 1 plus 4 equals 6. Can you divide 6 by 3? Yeah, it makes 2, so this is true. 114 is divisible by 3. It's amazing, isn't it? All right. 3, 5 is a factor of 108. We're looking at the last digit. If it's a 5 or a 0, it works. It is not, so this is false. 4, we have the last digit 0. Look, this one is 400 can be divided by 10. That is true. All right, let's look at the next one. Hopefully we got some more that we can practice. Use the divisibility rules to answer each question. Why is 578 divisible by 2? Well, we know that the last digit is what we're looking at. We're looking to see if it's 0, 2, 4, 6, or 8. It is 8, so why is 578 divisible by 2? The ones digit is even. That would be a good way to answer that. It's true. Why is 3 a factor of 120? It is. 1 plus 2 makes 3, plus 0 makes 3. 3 divided by 3 works. It makes 1. So what we're going to do is we have to find out a way to put that in the words. So we're going to say the sum is divisible by 3. All right. 3. Why is 105 divisible by 5? One's digit is 5 or 0. Right? And 4. Why is 10 a factor of 40,000? Last digit 0. One's digit is 0. All right. Pretty straightforward, I hope. If you're in with our live session, we're going to be talking about this and probably working some on your homework together because it's going to be hard. So homework. Here is your homework. You're going to go through each one of these numbers and get true or false. We might do this together, so it's worth being live. All right? We're going to circle them. Then down here, I want you to practice answering those questions the same way we did up here on slide 6. It's going to be close to the same answers. And then 21 and 22, we're going to fill this in to make a new number, right? That makes this true. 99,990 blank. What can we put into that blank to make numbers that are divisible by 2? What can we put at the end of 8,750 blank to make it divisible by 5? This one you should have 2 answers. This one you'll have 5 answers. All right? All right.